Switch is a single broadcast domain device. Switch is a what do you mean by broadcast? Broadcast means send this thing to all, right? Broadcast means send this particular thing to all, right?
Yeah.
So let's say if a if if D wants to communicate with E and don't know the MAC address of E, it will broadcast the frame, right? It will broadcast the frame, and when switch receives the broadcast frame, it will forward the broadcast frame to all other ports. So it means from broadcast point of view, every port are in a same group. So switch is a single broadcast domain device.
Yeah.
Switch is a
So one thing.
yes.
When it broadcasts, like if it's another switches are connected to the ports,
Yes,
they also
yeah,
broadcast, right?
yeah. They are also broadcast.
Uh,
Okay, so they are also broadcast. Okay, so from broadcast point of view, every port of switch are in a same group. Okay, so switch is a single broadcast domain device.
yeah.
But from collision point of view, it is a multiple collision domain device which does not forward the collision received on one port to another port. Let's say hub is connected over here and it gets collision. That collision frame will go to G, H, F and 4. So switch is an intelligent. It will detect that it is a collide frame. Right. It is a collide frame and it will not forward to any other port. So it means every port is a member of different collision domain. Got it? In
Okay.
short, if switch receives a collide frame on one port, it will not going to send the same frame to other port. So from collision point of view, switch is a multiple collision domain device. From broadcast point of view, switch is a single broadcast domain device. Is it clear for you?
So the collision wave of point, it will be multiple collision, isn't it?
Yes, it is a multiple collision domain device.
Multiple collision domain,
Yes.
and broadcast, it would be one
Yeah,
single.
it will be from single broadcast point of view. Okay.
Yeah.
All right. So this is all about the switch. So Dennis, are you from originally from Australia or from any other country also?
From Sri Lanka.
Okay, okay. So that is why your tone like I have a Sri Lankan student also. Your tone is like Sri Lankan type. But
Okay.
good. Yes. All right, then. So till here you understand till switch.
Yeah.
And one more thing, Sri Lanka is very nice place to go with the families and all. Like beaches are very good and environment is also so clean. Like so clean, it is very good country, Sri
Okay.
Lanka.
Have you been there?
No, I've not been. I've seen the photos and videos. It is a very nice place to go on vacation with the families.
Um,
It is very clean. Yes.
yeah, some of the beaches are clean, but I think um,
Okay.
yeah, a lot of beaches in north and west were untouched yet. So
Okay.
um, yeah,
Because here in India, the Sri Lanka is also a tourist place for Indians.
okay.
They are going with the families and all.
Ah,
Yeah. All right. So this is the theory of switch, which you can pause the slide and in video and you can just read the points and all. Okay.
yeah,
All right. So the next device is router. Router is also a networking device. Router communicates in different networks, right?
yeah,
And this is how router look like. Router is not in a round shape. To explain, we make a symbol round to differentiate between switch and router. But in real time, router look like this. Okay. So
yeah,
to make you yeah, so to make you understand what is the router, all right. First, I have to explain you how communication take place in different network in man and WAN. Okay.
yeah,
In man and WAN, how it take place. All right. So let's understand the scenario first. So let's say I am from India and you are from Australia. My computer IP address is 10001 and this is my MAC address AA. In Australia, another network is running 192.168.1.1 and this is your MAC address, your PC MAC address, right?
yeah,
Now I want to communicate with you. So you are in different country and I am in different country, right?
yeah,
So we both have to connect on WAN.
yeah,
So
yeah,
what I will do, see we both purchase the link from service provider. I connect to my India service provider. You connect to your US service provider or Australia service provider, right?
yeah,
So we both added a router because if you want to communicate in different networks, you have to use a gateway device called router.
hmm,
Okay, so that is why I have added a router instead of switch. All right. Now, so first of all, if you want to communicate in another network, so point number one, if you want to communicate in another network, the point number one is you have to connect a gateway device which is a router, right?
yes.
Point number two, you have to give additional IP address which is called default gateway, right? Default
Uh,
gateway, default
so
gateway we
that's
have to configure, yes.
yeah, that's the first number of the network, isn't it? Subnet,
Yeah,
subnet.
yeah, you can, that is the first, mostly it is the first number of subnet, but you can keep any number.
Okay.
Why we are keeping the first number? So that it cannot conflict with any another IP. Okay.
Yeah.
Instead of that, you can use any another number also. So we will give the default gateway and the default is default gateway. It is the IP address of your router.
IP address of the router. Yeah.
Yeah, the IP address of the router comes in default gateway. In this case, I have given 10.0.0.100. See, this is not the first number. First number I have given to PC. So it is not compulsory that in default gateway the first IP address will come.
Okay.
Okay. So it is
Okay.
not compulsory. All right.
Hmm.
Similarly, in USA also you also want to communicate in different network. So you also configure the default gateway, which is the IP address of your router, right?
Yeah.
Now in between, service provider is also there, and please listen carefully about this topology, because
Yeah.
the first practical which we are going to configure in Cisco Packet Tracer, we are going to configure this topology only. Okay.
Yeah.
Now in between, the service provider network is there. So service provider is using 172 network series.
Mm.
So it means in India 10 network is running, in USA 192 network is running, service provider is using 172 network range. Alright.
Yeah.
Okay, so this is our network. Now what happens? Switch maintains the MAC table to take forwarding decision. Right.
Mm-hmm.
In the same way, in the same way, router maintains the routing table
Yeah.
like this. So router maintains the routing table in which by default directly connected network routes are coming. See here, this is the India router, and two networks are directly connected, 10 network and 172 network, right?
Yeah.
So in India's routing table, it is C. C means directly connected. So we are here on router. All right.
Yeah.
We are here on the router, right?
Mm.
So this is my India branch office and this is my US branch office. And I was here. My router maintain a routing tables which by default contain routes of directly connected network only, right?
Okay.
Okay, so this C indicates means directly connected network.
I
So my
see. Yeah.
routing table, yeah, my routing table is showing that 10 network is directly connected with fast Ethernet. And always remember that routing table shows the network address, not the proper address, because router consider network. All right.
Network. Okay.
Yeah. So it is written as network address. All right. So it is showing that 10 network is directly connected with fast Ethernet and 172 is directly connected with serial.
Serial.
Similar, similarly, similarly, here also it is showing that. Similarly, here it is also showing on US router that two networks are directly connected, right? Two networks are directly connected. Okay, 192 and 172. All right.
Yeah.
So now let's say I want to communicate from India to US. So I am pinging from India to your computer. Okay,
Yeah.
and serial technology is using. We are using serial technology here. Now my computer will create a packet. Why I am calling it packet? Because at router level we called as packet. At
Yeah.
hub level, we called it a electrical signal. At switch level we called it frame, and at
Right.
router level we called it a packet. Okay.
Yeah.
So now my computer will create a packet in which there is a data. Source IP is my IP address. Destination is your PC IP address. Source MAC is my PC MAC address. Now here's the new point. Right now, till now, you have learned that in destination MAC address, your computer MAC address will come. Right. Alright.
Yeah. Yeah.
But that happen in local area network, not in MAN and WAN.
Yeah.
Right. In MAN and WAN, what happen? Your PC IP address will come in the destination IP, but in the destination MAC address, my router MAC address will come. All right.
Okay.
When source IP and destination IP, when source IP and destination IP are from different network, then destination MAC will be not your PC MAC address. Destination MAC will be my router's MAC address. Yes.
So when the packets reach the router, it's eliminate the destination MAC address and forward it to the source IP address. Sorry, destination IP
No,
address.
no. I will explain you each and everything. Don't worry. Just right now, just understand that in destination MAC address, your PC MAC address will not come because it is not going directly to your PC. It is going to
Can
my
you zoom a
router.
little bit the packet? Can you zoom that packet a little bit? I can take a like a screenshot.
See, see here. See.
Ah, thanks.
This is the packet.
Okay, thank you.
All right. Now,
Yeah.
so the destination MAC address, my router MAC address will come because my computer is not going directly to your computer. In LAN, my computer was going directly to your computer, right?
Yeah.
But here my computer will go, the frame will go to packet will go to router, then from my router to your router, then from your router to your PC. So what
Yeah.
my computer will do, my computer will give the MAC address of my router.
Okay.
Now the packet is ready. Now what happened? The computer sends this packet to switch and switch sends this packet to router.
Yeah.
Okay.
Yeah.
Now
So
as soon as router receives the packet, router will
one second. So when the packets goes to switch, it's check the IP address, isn't it?
no switch check the MAC address. Switch
Sorry,
work
yeah.
on MAC
Switch
address.
check the MAC address.
Yeah, it will.
Then that's the reason it's forwarded to the router.
Yes,
Okay.
because switch maintains the MAC table, right?
MAC level, yeah.
It will showing that on port number 2, on port number 1, RR is connected.
Mm.
This is the port number 1.
Oh,
And
okay.
on port
Got it.
number 2, AA is connected like this. So
Yeah.
when this packet arrives at switch, switch will read the destination MAC address, RR.
Yeah. All right.
And switch will take, okay, RR is on port number 1, and switch will send it to port number 1 like here.
Yeah. Got
Now
it.
you got it?
Yeah.
So when router receives the packet, it will read the destination IP address.
Mm.
Router will only ask where you want to go. And the packet will say that, okay, I want to go to 192.168.1 network. So router will tell that, okay, I maintain routing table. If I am reachable to that network, then only I can forward you to that network. Otherwise, I will discard you right away. Okay.
Mm.
So now what router will do? Router will check the routing table. So by default, there is no route of 192, right?
Mm.
This is not a route. This is the route which I have inserted. So if we're talking by default, if we don't give any route, then by default there is only 10 and 172 network routes are there, right?
Yeah.
So router will route the packet only if router is having route to reach the network. All right.
All right.
Now, so there are two ways of giving routes in router routing table: statically by administrator and dynamically by dynamic routing protocol. Statically means I will, as a
Manual
network
edit.
engineer, as a network engineer, I will read the topology and using my mind, I will tell that router that, hey India router, I know that you are not reachable to 192 network, but you are reachable to here, right?
Yeah.
India router can reach till here.
Yeah.
So I will tell my India router that, hey India router, do one thing. Whenever any packet arrives to you and tell that he wants to go to 192 network, then do one thing. Your next stop will be this. Just send the packet here, and the remaining thing will take care by the US router.
Mm.
Similarly, I will tell the US router that, hey US router, I know that you can reach 192 network. I know you can reach 172 network, but you are not able to reach 10 network, right? Because by
Yeah.
default 192 and 172 networks are there. So if you want to reach 10 network, then do one thing. Your next stop will be this IP address. Send it here. Remaining thing will take care by the India router. Okay. So
Okay.
this is how the static route I have given. So as soon as I give the static route, in practical I will show you how to give static route. Okay. So as soon as I give the static route, the S entry will come as stand for static. That to reach 192 network,
Yeah.
mask is 24 via 172.16.0.2, which is this.
Okay.
Similarly, in US router an entry will come static. To reach 10 network, go via this. This is called the next hop. 172.16.0.1.
Okay.
Okay.
What's in the bracket 1-0? Is that the Ethernet uh, port? Or no, that's the serial port, is it?
It's a serial port.
Serial port. Okay.
Okay. So now what happens? This packet comes to my router and tell that, hey, I want to go to this network. So what my India router will do? My India router will tell that packet that, hey packet, I will check my routing table, and if I have a route to reach that network, then only I will write a drop to you. Otherwise, I will discard you. All right. So what
Yeah.
my India router will do? My India router will go to the routing table and check whether he is reachable to 192 network or not. So yeah, he is reachable. There is a static entry, right?
Yeah.
So now my router came to know that he can reach 192 network, right? He can reach 192 network, right?
Yeah.
So now my router will modify the packet. Now router will modify the packet. How router will modify the packet? See here, like this. So there are two conditions. If you are using serial link, then no MAC address will use. Router will remove the MAC address because MAC address is used in Ethernet technology, not in a serial technology.
Serial thing. Okay.
But what about nowadays? Because nowadays we are not using serial technology. Nowadays we are using Ethernet technology, right?
Yeah.
So what happens nowadays if this packet arrives to router and router knows that he is reachable to this network. So nowadays router will modify and add the MAC address if this is Ethernet.
So router will add the MAC address of
MAC address of its India router RR
uh,
and your router MAC address SS.
SS. Okay.
This is called source MAC and this is called destination MAC. So nowadays we are using Ethernet technology. So what happens nowadays? When my router receives the frame, knows that it is reachable to this network, so my router
Yeah.
will modify the frame in which it will not touch the IP. It will only change the MAC address. Got it?
Sorry. I can you explain again?
Sure. When this packet comes to
Yeah.
my router and my router
Yeah.
knows that okay, I am reachable to 192 network, so my
Yeah.
router will modify the packet in
Packet. Yeah.
which in which it will not touch the IP address information. it will only change the source MAC and destination MAC.
Okay.
All right, it will only change this. In source MAC address, my router MAC address will come, and in destination MAC address, your router MAC address will come. If
So
we
one
are
thing,
using Ethernet technology, yes,
because we are using the Ethernet technology.
yes,
Okay, because before
because
that,
we are using, yeah. If we are using serial technology, then there is no MAC address. Only this frame will go.
frame will go. Okay,
Okay, no MAC is using serial technology.
got it.
Got it? No. So now what happens? This packet go to your router here, and your US router will receive the packet, and it will ask where you want to. Router will only concern about this where you want to go address. So the packet will say that okay, I want to go to 192 network. So this router will check whether I have a 192 network route or not. Yes, I have a route, right? In fact, it is directly connected to my router. Okay,
Yeah.
so means your router came to know that your router receive a packet which want to go to 192 network, and when your router check your routing table, so it is said that yeah, in fact it is directly connected. So definitely I can forward you to that network, right?
Yeah.
So once your router comes to know that okay, it can forward the packet to a particular network, so again the frame will modify. Again the packet will modify from here, and again in source MAC address your router MAC address will come, and in destination MAC address your PC MAC address will come.
Okay.
So at every hop the information will change about MAC address. See here. Now everything is same except the source MAC and destination MAC. In source MAC, your router MAC address is coming. In destination MAC, your PC MAC address is coming. And this is how your PC receives a packet from one destination to another in man and when. Got it?
Okay. Yeah, got it.
Now I will explain you what is router. So router is, see, this is very in depth I am teaching you. Okay, I can cover the topic router like this. Okay, router is a layer 3 device, it works on IP address, that's it. But I show you each and everything in a very proper manner as I promise you, right?
Yeah. Yeah.
Now, so let's discuss what is router. So first of all, router is an intelligent device, right? Like which is an intelligent device. So router is also an intelligent device. Now, what is the function of router? So router function is to route between networks, to communicate between networks, right?
Yeah.
The main duty of router is to communicate between networks, right?
Yeah.
So router is an intelligent device. Router route between networks. Router route
Route
between
between.
networks. Between
It
networks.
has a responsibility to deliver packets from one network to the other network.
Yeah, very correct. Yeah, very right. Okay. And plus one thing, router maintain a routing table, and router take forwarding decision on the basis of a routing table. So routing table is layer 3 table, hence router is layer 3 device.
Yeah.
In interview, they are going to ask you, router is layer 1, layer 2 or layer 3. So router is a layer 3 device. Why? Because router depends on routing table, right? And routing table is layer 3 table. So router refers routing table to take forwarding decision, and routing table is layer 3 table and router is layer 3 device. Okay.
Yeah.
And one more thing, no two port of router should be in different network. Every port of router should be in same different network. Sorry. Let's say one port of router is in 10 networks, so another should be in different network, because router work is to communicate between networks. So no two port router should be in same network. Okay, it should
Yeah.
be in a different network, because if you want to communicate in same network, then use switch. Why you are using router, right?
Yeah.
Okay, and plus I have shown you this, when routing table, when source IP, destination IP are from different network, then destination MAC will be our router MAC address. Okay, and router will only route the packet when it has route to reach the network. If we don't have route to reach the network, it will discard the packet. And router maintains the routing table, which maintains route of directly connected network only. We have to add a route in routing table. So there are two ways of giving routes in routing table: static and dynamic. In static, we manually configure the router, that where to go and what will be the next hop, right?
Yeah.
And
Yeah.
in any and dynamic, we configure a software which is called a protocol, which guides the router that which path is the shortest path for the router.
Mm.
All right.
Yeah.
Plus one more thing,
Yeah.
every port of router is in a different broadcast domain. Let's say if
I
router
agree.
receive a broadcast on this port, then router will not going to forward the broadcast on another port. So every port of router is a member of different broadcast and different collision domain. Router don't forward the broadcast receive on one port to another port. Similarly, router don't forward the collision receive on one port to another port.
Okay.
All right. So from broadcast point of view, router is a multiple broadcast device. From collision point of view, router is a multiple collision domain device. Clear?
Yeah.
All right. See, this is the theory. I'll slow down the process so you can read it while watching the video. Okay. So
Yeah.
this is your router. Now let's see the difference between switches and, see, we have completed how many topics? We have completed the routers. All
Routers.
right. We have completed this thing. Okay. We have completed this collision and shared medium and all. All right. Now I will show you what is the difference between L2 switch and L3 switch. Okay.
Yeah.
See, L2 switch are those switch which only switch. L2 only do switching. Okay. Let's start the IP address. Wait, I'll show you in Paint. I'll show you the difference. I think there is a difference, but why it is not showing? Wait. Mm, yeah. Mm-hmm. Oh, where it is there? This. Okay, I'll show you by writing. See now what is the difference between L2 and L3? Okay. All right. L2 switch. You can also write it down in your book as well. Okay.
Yeah. I'm writing.
L3 switch. The first difference. The first difference is L2 switch. It only does layer 2 forwarding. Let's say only do layer 2 forwarding. Layer 2 forwarding, And what about L3 switch?
It
It does switching and routing both. It does switching and routing both. Switching and routing both. And it only does switching, right?
yeah.
Switching, switching and routing both. And it does only layer forwarding, which is called switching. That is switching. Okay. The first difference. It only does the switching and it does switching and routing both. Right. The second difference. The second difference is it's only work on MAC address. It's only work on MAC address. And about L3 switch, it works on both. It works on it works on MAC and IP address. All right.
Yeah.
The third thing is about layer 2 switch. It only maintain MAC address table. It only maintain MAC address table, whereas in L3 switch, it maintain both. It maintain both routing and MAC table. It maintain both. Third thing is you cannot configure IP address in layer 2 switch except management IP. I'll show you what is this. Fourth, you cannot configure IP address in L2 switch except management IP. Except management IP address which is given to VLAN 1. Which is given to VLAN 1. So in L2 switch, we cannot configure the IP address. So if you want to configure the IP address, then we can configure for VLAN 1. Okay.
Okay.
Now, what about the L3 switch? In L3 switch, we can configure the IP address. Here, we can configure the IP address on a particular port after giving command, because by default L3 is a switch, right? So we have to give command. After giving command, no switch port. Means what we'll do, we'll go to the L3 switch and we'll tell that, hey L3 switch, in right now this port is not a switch port. Now consider this port as a routed port.
Okay.
So after giving no switch port command, you can configure the IP address on L3 switch. Okay. So this is the major difference in L2 switch and L3 switches. All right.
Yeah.
Okay, you can take the screenshot as well.
All good.
Okay. So I have completed this point also. Okay. Now I will cover all these things. Don't worry about this. First, I am focusing line by wise, right? If I directly teach you anything, you will not get the point. So that is why I am going by my way. So now we'll do the IP addressing V4 and subnetting and all. But before that, we'll do the compare TCP and UDP. earlier in the CCNA, there is a whole OSI model and comparing the TCP/IP model to OSI model, right?
Yes, yes.
Yeah, but in new CCNA there is no OSI model, there is no TCP/IP model. It is just want us to know the TCP and UDP comparison.
Yeah.
So that I'll show you the comparison. Okay. But before showing the comparison, let first focus on IP because that is an important chapter
So
IPv4.
the ISO model is gone in the new CCNA.
Yeah, it is gone because see, in originally we are using TCP/IP model.
Yeah,
OSI model is only used to reference, right? Is only
yeah.
used for reference. In real time, TCP/IP model is used, and that is also in TCP/IP model we only concern about TCP and UDP. Okay, so that thing
What
we'll
about
do.
SATP?
SITP. What it is
S
SITP?
um TCP,
TCIP.
UDP, and
TCP/IP. Na? So this is the TCP and UDP.
okay. There is another one
This is
called STP or something. I can't remember.
I don't know. It's okay.
It
But
used
right now
for
let's
video streaming, fast video streaming protocol something.
I don't know. But CPOE I think you are thinking about. I don't know, sir. Let's focus on this another topic which is very big topic.
Yeah.
IP addressing and subnetting and plus we have to configure this. Wherever it is written that configure it means we have to do the practical also. Okay. We
Okay.
have to do the practical only. Plus, but I will explain the subnetting and also let's focus. So you already know what is IP addressing on all right.
Yeah.
But then also we'll do in a very quick manner what is IP address. So let's start. What is IP addressing and subnetting? So here you need the book at the time of subnetting, not right now. At the time of subnetting, you need the book. Okay.
Okay.
All right. So what is IP address? So IP address is of 4 octet, 4 byte, 32 bit decimal address, right?
Yes.
Okay. So in IPv4, one field size of 8 bit and total there are 4 fields. So if one field size is of 8 bit, then how much for 4? 32 bit, right?
Yeah.
So the size of IPv4 is of 32 bit because one field size is of 8 bit. So 4 field size is of 32 bit, right? So IP
Yeah.
address is of 32 bit. So I prove one point. 8 bit is equal to 1 byte. So for one field it is 1 byte. Then 4 field it is 4 byte. So
Yeah.
4 byte. Group of it is called octet. So this is 1 octet. So about 4 octet, right?
Yeah.
And it is a decimal address. Dot in dotted it is 10 dot 10 dot 10 dot 10, right? So this is a decimal address. It is not an hexadecimal address like MAC address, right? It is a decimal
Yeah.
address.
Yeah.
It is also called as layer 3 address and logical address, right? Now what is
Layer.
this?
Yeah.
Now what is this is called mask, and this is
Yeah.
very much important factor, right? Because without mask in IPv4 you cannot do anything, right?
Yeah.
And don't forget, mask shows how many bits are in a network. What mask shows? How many bits are in a network.
In the network. Yeah.
Mask shows how many bits are in a network. So now let's move ahead. Let's see here. So what is IP address? IP address is just a set of number. IP address without subnet mask is just a set of numbers. See the importance of subnet mask, right? Because
Yeah.
if it is not supported by mask, then it is just a number. All right. See now let's see the importance of mask. See, all right. Now in this is an IP address 192.168.1.0, right? And /24 is the mask. All right. Then
Yeah.
with the help of subnet mask, we can check how many bits are in a network and how many bits are in a host, because IP address is having two parts, network bit and host bit. All right. An IP address is having two parts, network bit and host bit. And with
Yeah.
the and with the help of mask, it is find how many bits are in a network and how many bits are in a host. So let's see. So here mask is 24, right?
Yeah.
24. And what mask shows how many bits are in a network. So here it is showing that 24 bits are in a network, right?
Yeah.
So now from where we should take the 24 bit, from here or here? So always remember that network bit starts from the left. All right.
Yeah.
So from here and host bit start from right. Okay. Host
Yeah.
bit start from right. So it means this 24 bit, one bit, one field, two field, three field, this is of 24 bit, right?
Yeah.
So this 24 bit is your network bit, right?
Yeah.
And remaining 8 bit is your host
Host
bit.
bits.
So this is the importance of mask, and why we are like this, taking out this network bit and host bit to find the network address and host address. See, if anybody asks you to write down the network address of this IP address and host address, so how you are going to write the network address? So what to do? Whatever bit or whatever field comes under the network, write as it is. 192, 192, 168, 168, 1, 1. And about the net host bit, consider 0
Okay.
/24. So this is how you are going to write the network address. What the host address? Write as it is, because without network address, host address is not written. Host address is supported by network address. All right.
Yeah.
Now it's your turn. Now I'm going to give you a sum. Okay.
Yeah.
Take your question. You take the two question. Let's say 10001/8. What will be the network address? And what will be the network
Okay.
address? Sorry, how many bits are in the network address? And what will be the host address?
Okay. Our network address should be 10.0.0.0.
Okay,
Host should be 10.0.0.1.
1. And how many bits are in a network?
8 bits.
8 bits. And how many bits are in a host?
24.
Very good answer. Now let's take another question. 172.16.0.1/16. Now what is the network address?
172.16.0.0.
Very good. And host address is as it is, right?
Yeah.
So this is the importance of your mask. So with the help of mask, you can find out how many bits are in a host and how many bits are in a network. And with the help of that, you can find out the network address, host address, subnet mask. So each and everything is going to find out by the network address, which is supported by the subnet, right?
Yeah.
Okay, let's move ahead. All right. So whatever IP address we write, let's say we have written that 10.0.0.1. So what is the minimum and where the maximum we can go, and why? With the help, with the perfect, what we call it, the perfect reason. What is the maximum limit of an IP address? where can a maximum particular field can go and why?
Maximum network address or maximum number of host or
I am asking this one. Like I have written 10, right?
yeah.
So from minimum, where can I start and maximum, where can I go?
I don't understand. Like
See,
what maximum?
minimum we can start from 0 and
Uh-huh.
maximum we can go till 255. In
Oh, yeah.
got it?
Yeah. Yeah.
So any field, let's say 0, 1 or 10, any field in IP addressing, any field you can start with 0 and maximum you can go to 255. You
Yeah.
cannot go to, yes,
Each 8-bit has 255. I think host.
yes, yes, not 255 host. Maximum, I'll show you, don't worry. So, first of all, till here everything is clear for you.
Yeah. Yeah.
All right. So, an IP address minimum start from 0 and maximum it can go to 255, 255 and 255, right?
Yeah.
All right. Now let's find out why it is maximum can go to 255, not to 256, 257 or 230 or 260, right? Let's see. So what we are going to find out, what we want to find out? We want to find out that in one field, because the result of one field is same for all four field, right?
Yeah.
In one field, why it is minimum 0 and maximum 255? So let's take it 1, 2, 3, 4, 5, 6, 7, 8. In one field, 8 bits are there, right?
Yeah.
And there are two possibilities are there. Two possibilities are there.
256. I think.
No, no, not 256. Possibilities are either it is a network bit or it is a host bit, right? There are two possibilities. Either it is a network bit or it is a host bit, right? So in this case,
Yeah.
this is a network bit. So what we have to find? We have to find that why is maximum 255, not 256 or 257. So to find out this, just take one field. One field consists of 8 bits.
Yeah.
And in 8 bit there are two possibilities. Either it is network bit or it is host bit. Right? Depend upon the
Yeah.
subnet mask.
Yeah.
Right? Now, so from that 8 bit, I take the 8 field and two possibilities. Got it? See, these are the
Yeah.
8 field of that one field and possibilities. Two possibilities. Two comes from possibilities. Okay? And always number always start from 0. So 0, 1, 2, 3, 4, 5, 6, 7. 2 power 0 is 1. Right? Anything raised to 0 is 1. 2 power 0 is 1. 2 1 is 2, 2 2 is 4, 4 2 is 8, 16, 32, 64, 128. Right?
Yeah.
Now, if I type 0, so no number is matching, right? No number is
Uh,
matching.
no. No.
So all 8 bit will 0. So in binary, 0 will look like this. 0 will look like this in binary, right? All 8 bits are 0. So now you tell me any number between 1 to 100.
1 to 100.
Any number, your favorite any number. Not from
Uh,
this, any number.
65.
65. So if I type 65, so in binary how it look like? 64
4 and 1.
and 1 and remaining all zeros.
Zeros. Yeah.
So this is how your 65 looks in binary, right?
Yeah.
1, 0, so 1. Now tell me any number between 100 to 55, any number.
100 to 250, 132.
132. So if I type 132, then 128 plus
Is
4 plus 2,
yeah.
right? So this is called, no, sorry. No, sorry. 138 plus 4.
Yeah.
138 plus 4 is 132, right?
Yeah.
So 128 will become 1. 4 will become 1. Remaining all are 0. So 132 look like this in binary, right?
Yeah.
But if I type 255, so if you add all this, it become 255. All are ones. So it means that in an IP address, total there are 8 bits, and there are three possibilities. Either all 8 bits are 0, or all 8 bits are between 0 and 1, and all 8 bits are total 1, right?
Yes.
If all bits are 0, then answer is 0. So this is the maximum. It is a minimum, sorry. If it is 0101 mix, then it will be any number but less than 255, right? Less than 255. Any number but less than 255. And if I make maximum, what can happen? All bits are 1, right?
Yeah.
All bits are 1. This is the maximum, right? So that is why we can go maximum till 255, because in one field there are total 8 bits, and if all 8 bits are 1, then answer is 255. All right.
Yeah.
So the IP address range is start from 0 and 255, and it is included of 0. That is why at the time of writing total we write 256, because 0 is included. But at the time of writing the IP address, maximum we can go to 255 because of this. In one field there are total 8 fields, and maximum all bits are 1. And if all 8 bits are 1, then answer is 255.
Okay.
Got it?
Yeah. So yeah, the minimum is 00. It's it doesn't
Yes.
consider.
Yes. 0 is count. Sorry, in IP addressing 0 is count.
Okay. Network
So
address.
that is yeah. That is why it is total
No, that's a
256.
broadcast.
255 is a broadcast address,
Yeah.
and 0 is a network address.
Address, yeah.
All right. So can I move ahead?
Yeah. Yeah. Yeah.
All right. All right. So now mask. Three types of mask: prefix mask, subnet mask, and wildcard mask. Okay. So there are
Yeah.
three types of mask: prefix, subnet, and wildcard. Now how to find it? It is very simple. We are using prefix mask, right? So let's take
Yeah.
this IP address 172.16.0.1 slash 6. It is the prefix mask, right?
Yeah.
Now 16 means 16 bits are in a network. So let's take this 16 bits are in a network. And one more thing, network bits are always 1. Okay.
Yeah.
Network bits are always considered as 1. Host bit are always considered as 0. All right.
Yeah.
This is 0, this is 0. Host bit are always considered as 0. So this is 16-bit or host bit, so 0 and 0. Now, with the help of this, we can find out all this. So how can we find out? See here. If all bits are 1, then answer are 255. Right?
Yeah.
Then dot. If all are 1, then also answer is 255. Then dot. If all 0, then answer 0. If all 0, then answer are 0. So this is how we find out the subnet mask. You got it? Understand this one?
Yeah, it puts like network address all ones and 0 for the host part.
Yeah, this is the host. Okay.
Yeah.
Now, how to find out the wildcard mask? So this is formula, very easy formula.
Yeah, it's
Subnet
opposite of
mask
the
less by
subnet mask.
no, not the opposite. If you do the opposite, then it will wrong. Because what the subnet mask is 250. What if see? What if the subnet mask is 255.255.250? Then what will be the wildcard mask? If you do the opposite, then it will wrong. So opposite no. So wildcard will be 0.0.0.3. Sorry, 0.0.3.255. Got it?
Yeah.
So it is not the opposite. It is less by 250. Subnet mask less by 255 is your wildcard mask.
Okay.
You understand this point? So it
Yes.
is not the opposite. It is less by 255. Got it? So
Yeah.
255 minus 255, 0. 255 minus 55, 0. 255 minus 0, 255. 255 minus 0, 2. So this is how we get the wildcard mark. Got it?
Yeah.
Now I have a question for you. You have to solve. Okay. Suppose this is the IP address 10.0.0/8.
Yeah.
This is the prefix mask. Then what will be the subnet
Subnet mask.
mask? And what will be the wildcard mask? Please tell me.
Subnet mask will be 255
Mhm.
0.0.0.
All right.
Wildcard should be 0 dot 255 255 255.
Very good. Okay. Now let's take another example. 192.168.0/24. What is the sub?
255 dot 255 dot 255 dot 0.
Okay. What will be the wildcard?
0 dot 0 dot 0 dot 255.
So I understand how to find out this now
Yeah.
technically. All
Yeah.
right. Okay. Very good. Now host per bit. Host per bit means like with the help of one bit, how many IP address we can make. This is called host per bit. Okay.
Okay.
So this is the formula, and I will explain in a more better way. See here. See here. So let's say there is only one bit. So
Two
with
hosts.
the help of one bit, how many IP addresses we can make two? How? So one bit is represent is two power. How one bit is represent? Two, and one comes in power. So two power one is two IP address. So with the help of two bit, how many IP address we can make? So two
Four.
power two. All right. So two. Now I have
Um,
a question for you. Okay.
yeah.
In the same way, yes, yeah. Please tell.
Even though it's like 2 to the power 2 is 4, we leave the network and the broadcast, isn't it? Like only two.
Yeah, we leave the network and broadcast address, but that is another thing in subnetting we'll see. Right now, just understand the concept.
Okay.
Okay. Now I have a question for you. Let's say we have a we have a 16 bit. We have a 16 bit. Then how many IP address we can make? And if we have a 24 bit, then how many IP address we can make? And if we have a 8 bit, then how many IP address we can make? You can use the calculator.
Yeah, 8-bit, I think it's 256.
256. All right.
16-bit.
Sorry, 8 bit. 8 bit is 256. Wrong. This is wrong answer. Oh, sorry. 2 power 8. Oh, sorry.
Yeah.
Now what about 24 bit?
24-bit.
You can calculate. You can use the calculator in your laptop. Scientific calci mode. Do you know how to calculate? I'll show you.
Take the.
Just go to calculator and see here 2 and this x raised to 2. X raised to y, I think. X raised to y is the power. Power
Okay.
answer is 1 crore 67 lakh 77,216. 1 crore 67 lakh 77,216. What about 2 power 16?
Sorry, how to use that square?
X power y.
X power y.
Yes. Yes. I'll show you one more time. See 2 and press x power y. That is power 24. So here you get the answer.
It's something around 16777216.
No, 6,536. 536. Your calculation is wrong. See here. 2 power 16. Oh, sorry. 65,500. Sorry. 65,536.
Yeah.
Okay.
Yeah.
So this is called the host per bit. So with the help of host per bit, you can calculate that how many IP addresses there in your network. So let's say for an example, for now it's I'll show you one example, then you have to find out. So let's say that this is your office. Oh, so let's say this is your office, okay, and this IP address range is running in your office 192.168.1.0/24. So you can find out that how many IP address in your office is there. So 24 means 24 bit in a network. So means in host there is 8 bit, right?
Yeah.
And 8 bit is written as 2 power 8 means 256 IP address is there in your office, right?
Yes.
In which two IP address is not used, network address and broadcast address. Now you find out, I give you question, you find out that 192.168.1.10 1.0/27. This is your office network and find out how many IP address in your office, IP address in your network. Now find out, please find out how we are going to find out.
Uh,
It's very simple. You can take help of this.
32?
See here. You can take help of this. Instead of 24, it is 27.
27, yeah. 32.
So it means 32 IP address is there in your office, right?
Yeah.
Because 27 bits in a network. So total IP address is of 32 bit, right?
Yeah.
From 32 bit, if you less 27, answer is 28, 29, 30, 31, 32, 5. So
Yeah.
5 bits are in a host, right?
Yeah.
5 bit is represented as 2 power 5. 5 bit is represented as 2. Where is the power option? 2 power 5. So 2 pi power is equal to 2 and the 2 to the 4 to the 8 in 32. So 32 IP address in your network. Got it?
Yeah. Yeah.
So in this way, with the help of mask, you can find out how many IP address are there in your network. All right.
Yeah.
Now let's do the class of address. So IP address range is from 0 to 255, right?
Yeah.
So this 255 range, INA, Internet Assigned Number Authority, not INA, it is INA, Internet Assigned Number Authority, INA, right? It is the INA who divides the range of IP address into 5 class A, B, C, D, and E only for distribution purpose. Okay.
Yeah.
INA divide the class of address 0 to 255 range, okay, into 5 class only for distribution purpose. Now just give me a minute. So the INA divided this range from 0 to 255 into 5 class. Okay.
Yes.
Now let's see the range. Here is the range 0 to 127 it is. So why it is 126? Because 127 is a universal loopback address, right? It is not
Okay.
configured and it is used to check the network card to, it is used to block the websites and all. Alright. 128 to 191 B class, 192 to 23 C class, 224 to 239 D class and 240 to 255 E class. Alright.
Yeah.
So let's see the full here. See here. If you see here, all right, see. So the class A, class B, and class C, these three class are giving range of 0 to 126, 128 to 191, 192 to 223. And for class A, we have given the default mask of /8, class B 16, and class C 24, right?
Yeah.
Class D 25, right? Now 24, and this is the subnet mask we have calculated earlier, right?
Yeah.
/8 subnet mask is this, 16 this, and 24 this. Now we also calculated this one. Okay, we also calculate this one. Like let's say in class C, 24 is the subnet mask. Okay, if 24 is the mask, means 24 bit network, right?
Yeah.
It means 24 bit in a network. So if 24 bits are in a network, then how many bit in a host? 2 power 8, right?
Yeah.
So 2 power 8 is 256 IP address. Similarly, in class B, 16/16 is the network mask and 16 bit in a host. So this is the answer. In class A/8 is the mask and remaining is 24 in a host. So how many hosts? 1 crore 67 lakh 77,216 IP address we have in class A, right? So INA divide this three class for distribution purpose, and this is called the public IP address. Okay,
Okay.
public IP address means if you want to access the internet, then you have a range from 0 to 223. From 0 to 223 you have a range. Between this range you can use IP address to access the internet connection. This is called the public address, and it is divided into class so that it is recommended for the company. Let's say my company is very huge. We are having a 1 crore employees in our company. So it is recommended to buy A class IP address because in A class we have 1.6 crore IP addresses. If my company is of mid size, then it is recommended that I can use B class IP. If my company is small size, then it is recommended to use C class IP address. Okay.
Yeah.
Similarly, this D class and E class, they don't use. They are not usable IP address. D class is used for multicast purpose and E class is for research purpose. Now, what does it mean?
No idea.
Multicast purpose means all the live streaming are captured and sent on this address. We are watching the cricket match, right?
Yeah.
Cricket match live streamings are captured and sent on multicast address. Plus the routing protocol which is using in router, which is running in router. So that routing protocol is using the multicast range to send the bit. Okay. So
Yeah.
multicast range address is that address which is already some software address. It is not configurable. It is already predefined address on software. It is not configurable for internet connection. Got it?
Yeah.
And research purpose means this range is for research group of members. So I have not seen in my life where it is used. So it is used for research groups of members. So research groups members are using this range. All right. Now,
Okay.
after the problem is that is A class, B class, C class. This is your public IP address. If you want to run the internet, you can use this range of IP address. D and E class is not usable. 127 is universal loopback address, not configurable. Then what if I want to communicate between 5 computers at my home and I don't want to access the internet? So should I purchase the IP address? No. So people are start shouting. People are shouting that okay, we are not using internet in our home. We have 10 computers and 10 employees. We are working and we want to share the data. So without IP address, we cannot share the data, right?
Yeah.
So for 10 people, we are not buying the IP address because we are not running the internet. So that is why the INA, which is Internet Assigned Number Authority, which handles the IP addressing, is given the private IP address. This is the private IP address 10.0.0.0 to 10.255. From A class, INA given the range of 10, which is your private IP address. We can freely use it. There is no charge. From B class, INA gives the range of 172.16.00 from 170 to 31 till 31. 55255. This range is private. You can use this range free of cost, no charge. One from C class, 192 range is allotted free of cost. So this is called the public IP address or private IP address. We can use this IP address free of cost, no charge. But we cannot run internet by using this IP address. So now you will say, okay, but in my computer, this IP address is configured and I am using internet. So this is happened because of netting. Netting topic will come afterwards. So all this happened due to the netting. Nets convert private IP into public IP.
Okay.
So are you understanding this for this class of address?
Yeah. Yeah.
All right. Now, now classless and classful IP address. See what is classless and classful IP address? Watch this. Let's say 10.0.0.1 slash 8. So the IP address belongs from A class. How can we find out that this IP address belongs from A class? By watching the first bit. Okay. If you want to know whether this IP address from A, B or C class, just see the first of it. So it is a class IP address, right?
Yeah.
And slash 8, this is also A class subnet mask, right?
Yeah. Yeah.
So this is called the class IP address. Classful IP address means that IP address which is that IP address which is IP address and subnet mask are from same class. But what if 10.0.0.10/24 is there? Now here IP address is from another class and subnet mask is from another class. So
Yeah.
this is called the classless IP.